Welcome to qnawire.
So here we're given two cars that are trying to make it through an intersection. And for the first one, we have it starting with a velocity going through, and the second one is just going to be going from rest and accelerating. And so we have 10 meters here, and the first stoplight. And then we have another 15 meters, and then 50 meters, and then another stoplight looks like, and then another 15 meters, and then 70, and then the last bit is 15 meters. And so our total distance here is just going to be the sum of all of these. And our car is starting at 50 kilometers per hour. So I want to convert that to meters per second because I'm going to have to do some unit conversion at one point. Might as well do it with this number. So we'll convert the kilometers first. In 1 kilometer we have 1,000 meters. So those cancel. And in 1 hour there are 3,600 seconds. And then we get meters per second like we want. And this is just 13.9 meters per second. So that's the speed of the first car. And we also know we have 13 seconds to try to make it through the intersection. So we'll see if either car makes it. So to start, the first car is just going at a constant velocity. So we know our displacement for that car is going to be Vt. And now if we want to know the total time it takes to reach the end, we can just do delta x over v. Our delta x is the sum of all these, so 10 plus 15 plus 50 plus 15 plus 70 plus 15. Hope that's right, yeah. And our velocity we just calculated is 13.9 meters per second. So this is a total distance of 175 meters over 13.9 meters per second. It's going to give us about 12.6 seconds. And so if we have 13 seconds to get through the intersection, it can do it in 12.6. So the first car makes it. Now the second car, important to note, it's starting from here. So its total distance is going to be not 175, but 165 meters. And so first it's going to accelerate to the speed limit. So I'll find out how far it gets during the acceleration. So for the second car, we're starting from rest. So our initial velocity is 0. And we're accelerating up to a velocity of 13.9, same as the first car. And we also are given that the acceleration is 2 meters per second squared. So first I want to find the total distance it gets in this interval. So we can use the equation of final velocity squared is the initial velocity squared plus 2a delta x, and now we're solving for delta x. So plug in 13.9, this is 0, our acceleration is 2, and delta x. And now this gives us 48.3 meters. And that's how far the car makes it during the acceleration period. And now it's going to go the rest of the distance at a constant velocity of 13.9 meters per second. And the rest of the distance we want, well, the total distance is 165, right? Because it's this distance from here to here. So this is 165 meters. And then we'll subtract out the first bit. Oh, that's a 3. And get 116.7 meters. So that's the distance that it has left to make. And we can use the same thing we did for the first car, where t is delta x over v, because it's the same thing, just starting from a different point. So our t for the second part is 116.7 over v is 13.9. And this is going to give us about 8.4 seconds. Now we also need to figure out the time it took for the first part, which is going to be, we can get it from this equation. This is the time it took for the constant velocity, and now we want to figure out the time it took during the acceleration, and then we'll add them together and see if it makes it. So our delta x we went is 48.3. Our initial velocity is the same, and our acceleration is 2. And from this we get t is about 6.95 seconds. So that's really t1, and this is t2. And so t1 plus t2 is 6.95 plus 8.4. And this gives us about 15.4 seconds. And that's longer than 13 seconds. So the second car does not make it through the light. And how much time does it miss it by? Well, it overshoots it 15.4. And we wanted to go in 13 seconds. So the second car misses the light by 2.4 seconds. And so we can see from here that the entire section that the first car traveled was at a constant velocity, and the entire section, the second part that the second car traveled, was also at a constant velocity. So in those two parts, we could use the same method to solve for the time. But in the first section of the second car, it was accelerating, so we need to use a different equation for that time. And then we could just add them together. We can't use one equation for the entire path of car 2, because it's accelerating for part of it and then not accelerating for another part of it. So we need to break it into two separate parts. But the first car does make it, 12.6 seconds. The second car takes a couple seconds too long and is going to get stuck at the light.